basically, when you get into the Kubernetes world, you go from having this one virtual machine to having multiple, like this explosion of all these different desired states and all of that. And you have to consider how do you protect it when bad things happen. Kubernetes is a way of running a workload in a cloud native pattern, but so is just running a Docker container. And so is, dare I get into Docker Swarm and Mesosphere and blah, blah, blah.
I say Mesosphere, isn't that some sort of Chinese food?
I'm not getting into that.
That's the soup.
We're used to protecting everything. That's just the way life is. You protect it all. But do you need to do that with the Kubernetes environment?
You have to take the same amount of care with regards to how you store your data, how your network is designed, how you deploy things, and how you back it up, as in any other kind of infrastructure.
How important is that data to us? If Microsoft turned around and they decided to charge on everything above 5 repositories, what would that do to our daily experience from a GitHub point of view? It'd mean that we'd have to go and do something with that. Now, imagine that from a company perspective.
Hello, everybody, and welcome to this podcast today. Once again, we are joined by Michael Cade. Thank you so much for coming back, Michael. Much appreciated.
Hey, everyone.
Nice to have you with us. So Michael is, we were discussing this last week, Michael is Global Field CTO. Veeam, that doesn't mean he spends a lot of time in a field, but or at least, unless that's part of your job description.
I do actually live in the middle of a field, but in a house in the middle of a field. But yeah, that's not where the title comes from. Generally, like it's just a posh title for a technologist.
Right. Okay. Yeah. Okay. Good. Although I do like it, the fact that you're field CTO and you live in a field. That's great. So one of the things that we were discussing last week, hopefully you caught the podcast. One of the things we were discussing last week was essentially Kubernetes and the way that I suppose all of our lives are evolving into utilizing it moving forwards. So it may not necessarily be for everybody yet, but it's definitely something that everybody touches at some point. Is that fair?
I believe so.
Nodding. Let's do nodding. Good. Okay, so actually, Christian, do you want to, or Christian Lehrer, do you want to raise the question on this one? Because I think we were discussing it before we started. What are the big challenges with regard to this, as far as you're concerned?
Yeah, being a Kubernetes noob, as I said last week, what are the challenges that you see regarding securing data, backing up data? You're working at Veeam, so I'm sure you have an opinion about that.
I do indeed, and I think we can go back and think about that virtual machine world beforehand, because I think it makes sense as to where we are or where we're heading as well. So if you think about a 3-tier app on a virtual machine, or maybe spread between 3 virtual machines, but ultimately that application, and you can go into services.msc, you can see a load of services around your application. And now think about them in the Kubernetes world. They all get broken out into individual pods or individual configurations within Kubernetes. And basically from that, if there's a service that requires some persistence, maybe that's your database, that's where we start to store that in a persistent volume claim, a PVC, you might hear it called, or a persistent volume. So basically, when you get into the Kubernetes world, you go from having this one virtual machine to having multiple, like this explosion of all these different desired states and all of that. And very much like a database server in your virtual machine world, you have to consider how do you protect it when bad things happen. And that bad thing could be a bad cyber attack, because that's what gets into the news every day. But ultimately, we all know that people just simply make mistakes. We all just mess things up because we're humans, and we accidentally...
We don't mess things up.
Yeah,
we don't mess things up. No,
I'm talking about them other people.
Yeah, those other people.
Yeah,
they mess things up.
The thing with Kubernetes though is the ability to mess up at scale. That's fun. if you really mess it up there, you can do it properly.
Yeah, really, exactly. And it could cost you a load of money as well. That's the kicker, especially if you're using one of those managed services, those Kubernetes managed services, EKS, AKS, etc. They're going to cost you a lot of money if you scale them up in a bad way.
Oh, true. So if you're out of control, yeah.
Yeah, and so hopefully that let's take what we already know from a virtual machine or a physical machine perspective. We've moved that into a container or a microservice. You might hear it, the terminology microservices.
Used to be called microservices, didn't it? A few years ago, back when cloud was more of a thing.
So, and I think we can still call it that. I think we have so much terminology that has been like bombarded to us over the last 5 years, 10 years of this cloud, because then you've got cloud native as well. What's cloud native and what's Kubernetes? Well, Kubernetes is a way of running a workload in a cloud native pattern, but so is just running a Docker container, and so is
serverless.
Dare I get into Docker Swarm and Mesosphere and blah blah blah. Like there's lots of different cloud native patterns that we probably.
I'm going to say Mesosphere. Isn't that some sort of Chinese food?
I'm not getting into that. It's a very salty soup.
Yeah, it's a very salty soup. Yeah. So, but no, and this is it. But and this is why it's quite confusing for the layman. Exactly what Christian says is the fact that a lot of people have heard serverless. I don't know, cloud native. What was the one I came up earlier? But yeah, whereby they've got many different names for what, to a certain extent, are fairly similar technologies, or they all solve similar problems. But it makes it very difficult for the average Joe in the street to understand, how those elements work. I mean, from a backup perspective, do you need to back up everything? We're used to, as backup providers, certainly, and as people who are running IT systems, we're used to protecting everything. That's just the way life is. You protect it all. But do you need to do that with the Kubernetes environment?
Yeah, so the way in which we approach it is from a Veeam Kasten for Kubernetes perspective is, so Kasten gets deployed inside of the Kubernetes cluster. So if you've got 10 clusters, you've got 10 instances of Kasten, and then it's federated by a multi-cluster view, so you can see all of them under one roof. You don't have to go to 10 different interfaces. But then we're going to back up everything under a namespace. So a namespace in our world is an application. You could traverse different namespaces. Generally speaking, you could think about a namespace being like this isolation zone for your whole application. This where you're
basically a resource pool.
Right. That's a very good way of putting it.
Yeah.
It means you can traverse outside, but you don't need to. So let's keep everything in this box. And then from a Kasten point of view, we're going to protect everything in the box. Now, when we protect it, that's going to be right down to your PVC. It's going to be down to your deployment manifest. So a deployment is a desired state. This is what I want you to run. This is the scale I want you to run at. And hopefully you're going to get to that scale dependent on the characteristics of your cluster. It's also going to pull in the images that you need from your Docker Hub, for example. Now, we are not going to protect Docker Hub. We're going to pull down that deployment, because then when we restore it somewhere else, you should go and get that again. You should go and get that version of the container that sits in the pod, and you should go and pull that again. Now, we're going to bring down the code, the manifest. We're going to bring the storage, the system volume claim, the potential database file, and we're going to get that to wherever it needs to be. But ultimately, you're going to bring down the container. Now, there's a big caveat there in that we do support things like image stream in Red Hat OpenShift. So image stream is their localized Docker Hub, if you will, container, resource registry, whatever you want to call it. But we will protect that. But we're not going to go and protect GitHub registry or Docker Hub or anything like that. The best practice should be go and pull that down again.
But if let me just try to get that straight. So if Docker Hub then would be offline, you would have a problem with restoring it. Because that is what I'm always thinking about. We're so fast in updating images, updating like version numbers there and there and there. And when we have some development or some software, whatever, some application that needs to be compliant in a specific state that has been defined and whatever, I think you have to also make sure that everything that is needed to build that in exactly that configuration needs to be backed up also, isn't it?
100%.
So how would we go with that?
So we do see a lot of customers where they'll self-host services like GitHub Enterprise, they'll self-host GitLab. And in which case, we protect that as well.
Okay.
What I'm getting at is that, but don't get me wrong, I think this is one thing that we didn't ever have to do from a virtual machine standpoint. We never had to worry about the off-the-shelf software. We never had to worry about the Exchange media and backing up the ISO for Exchange.
Yeah,
it was
because it was always
3
available.
Years, so
it was.
No, it was also self-contained, right? So if you took a backup of a VM that was provisioned on a given version of a specific ISO, that entire thing was contained within the VM. So you didn't have any external dependencies for that VM in itself. It might have external dependencies to other services, but not. It was self-contained, really. But that's why a bunch run their own private registries locally, right? So you have your own specific ISO files, your own specific images for the specific versions hosted on your own infrastructure, so you don't have an external dependency on that.
Yeah. So if we think of this, and again, I'm going to take it back to the thing that most people understand, which is virtual machines and operating systems. So essentially, you have your operating system for Windows, let's say, and you have your application, which is SQL. And like you say, they both come on 2 different CDs that they used to, at least, or DVDs. So you have those, and you install those as a container or from your repository. But you don't need to back those up, because the fact that they are hard copies of an instance that is completely available wherever you go. The only thing you need to change, and you do on your local machine, on your VM with Windows and SQL on, is you change the configuration on that to match what you need. But that information is what you need to protect, because that's the stuff that's not standard.
Exactly.
So really,
that.
It's a very little bit of information that you need to protect. Everything else is freely available.
Exactly that. And I think that generally comes in the form of a YAML manifest. So YAML, yet another markup language.
Go on. What is yet another market language? Yeah, that's right. Yeah,
exactly.
love YAML. Yeah, okay, good.
And it's just a desired state of, this is what I want this to look like, and whatever this is. And that could be that could be a service within Kubernetes, that could be a pod, It could be a deployment. Everything in Kubernetes is defined by a YAML. So it looks and feels the same. It's repeatable in that. Some people love it, some people hate it, but ultimately that's what.
There's a space in between.
I'm going to say, I think I need to be wearing sandals for this. I think it's one of those. I need to grow a beard like you guys. Yeah. Clearly, that's.
But the kind of true beauty of, be it YAML or be it some other format like it, I mean, the format doesn't really matter here. But the thing is, once you have defined everything in a specific way, in a specific file, you can have revision control on that, right? So next time you deploy and you tweak something, or you change a component in your deployment, you take a copy of that original file and then you tweak it around and you test it, and then you put it back in production. And then it recreates everything for you based on your new specification. So that way you can also have configuration management for everything in a way that's easily backupable as well. And with revision control, you actually know how it's deployed. If someone gave me an Ubuntu ISO and told me to set up a VM, how do you easily get my configuration of that out of it and make it reproducible? It's not that easy, right?
Well, you'd have to template it. You'd have to just take a copy of that image and send it somewhere else, wouldn't you? But
and then you have to actually take care of that image through X amount of revisions.
And every time you power it on and it does this little update, it's then immediately no longer consistent.
Exactly. And once you have that in text files, which is basically what YAML is, you can do CI/CD pipelines, you can do revisions of them, you can keep multiple copies without having to store 10 gig ISO 15 times, right?
Yeah, exactly. No, it's true. It just goes to prove how much we love an acronym, though, doesn't it? I mean, it's like we can't have anything without at least 15 acronyms bound to the end of it.
Yeah. YAML is good in that way. Yet another market language as its own abbreviation is beautiful.
I think to Christian's point, though, so Christian, white shirt Christian, reminded me that the word was private registries. And then Christian's point about how do we protect the container image, I think that's becoming more and more of a conversation that we're having as well across the I'm not going to use another acronym. Another
Go on.
software.
You know you want to.
Across the software development lifecycle, or the SDLC. There you go. I'll make sure I use it. But also about source code repository. How do we protect GitHub? How do we? So it's all well and good to have it on Dave's laptop, but if we think about where we're storing, and I imagine all of us have a GitHub account with GitHub repos in there that have been active, not been that active, and everything in between. And how important is that data to us? Like if Microsoft own GitHub, if Microsoft turn around and they decided to charge on everything above 5 repositories, what would that do to our daily experience from a GitHub point of view? It'd mean that we'd have to go and do something with that. Now, imagine that from a company perspective, like all of Veeam's, at least from a custom point of view, is stored on GitHub as well. That would change significantly how we use that source code repository compared to GitHub, GitLab. And I think people are starting to ask us, well, how do you protect Azure DevOps? How do you protect GitHub? How do you protect GitLab? How do I move between the two? And I think that's also becoming, to Christian's point, I think that's becoming an interesting discussion to have as well. It can't just live on a developer's laptop, because potentially, like if I was a bad person and I wanted to cause some problems, I would probably go hunting for source code and implement some change there.
Exactly. And that's what we saw already, right? We saw that.
Exactly.
And,
JQ is exactly that, right? Yeah, exactly.
Exactly. So,
yeah. Dodgy.
Speaking of Dave's laptop, how can we use Veeam or maybe also other backup software in creating test data? Imagine something like you have an application, you protect your PostgreSQL database entries, whatever. Wouldn't it be a great thing if you could use your backup software as in the past to create some sample data, test data for other deployment branches and stuff like that? Is that possible?
Yeah, exactly. So exactly what you just mentioned. In that use case, that's just Postgres. So if we're using Veeam Castle, it doesn't matter. This is the same as if it was a virtual machine, a cloud-based workload, etc. But let's talk about the Kubernetes side. If you're running Postgres inside of your Kubernetes cluster, you're using Veeam Castle to protect that into an S3 bucket or whatever. You've got the ability to restore that into another Kubernetes cluster, into the same one if you want, into a different namespace. You can pick and choose what you bring back from a granularity point of view. And then you could use that database again. Like it's just Postgres at the end of the day. So we've got the ability to not only back up and recover things when bad things happen, but also leverage that data. And that's Veeam has always had that story around Veeam Data Labs or leveraging data, getting insight from that data. And again, it's just another database as well. Where I said about Kubernetes just being another platform, Postgres is Postgres, looks and feels very much the same as what it does on a VM to what it does on a Kubernetes instance to what it looks like in RDS as well.
And the whole kind of the way Kubernetes does networking and does namespaces and does storage and does everything makes it really easy to kind of create a development branch of your production environment with a copy of the latest backup or whatever of your real live database and just mount it up and run it in a different namespace, and it doesn't interfere with the original one. While on VMs, if you wanted to do that, you needed to kind of re-IP things and make sure that things didn't connect with each other, and you created those virtual labs that Veeam had or has. But it required more effort on the infrastructure side to actually separate things. In Kubernetes, you don't have to do it in the same way. You just deploy it in a new namespace and you have a different ingress point to it, and that's your development part of it.
So I've actually done a session on exactly that, Christian, is being able to not only take a backup between version 1 to version 2 to version 3 of your application and making sure. So generally speaking, like if you think about Git being the source, like the single source of truth is your GitHub repository or GitLab repository. And if you go from version 1 to version 2, everything's captured in code and it gets deployed out into your, whatever that environment may be, whatever Kubernetes cluster that may be, except for your Postgres or except for your data service. Your data service, if you've written a new table or a catalog to said data service and you release version 1 and version 2 and version 3, that database doesn't change, or at worst, it gets wiped, especially if you make a mistake. So what the session that I've done is integrating your backups into your CI/CD pipeline. So making sure that when you go from version 1 to version 2 to version 3, before you even hit go, you're taking a backup of that database, because it's very easy in code to say, okay, I can drop the database. Like any of us on this call can drop that database very quickly. And that's a bad thing depending on what that data is. If it's a demo, it's obviously a good thing. But
well, as I said, you can fail massively, right? You can fail at scale. Yeah.
And take that in reverse as well, is that maybe you've got CI/CD pipelines for your pre-prod, your prod, your test dev environments, and you want a copy of last night's backup as the source of truth. Well, let's just then restore that. So as much as I'm saying backup between version 1 and version 2, well, now I want you to restore last night's good backup or the hour ago backup into this particular cluster that will give our DBAs or give our developers the ability to work with that data. Now, one thing that we won't do is we're not going to mask that data yet. Like in terms of what that data is, it's going to look and feel exactly the same as it does in production. And if that's an important database with loads of important personal identifiable information, then it's going to all still be in that database. Now that developers potentially got access to that. So, but you could see that we're actively thinking about, okay, how do we help that? How do we mask that data so that you can better use that in that scenario?
So do you encrypt it, or do you just not take it?
So
from a masking perspective.
Yeah, so we encrypt the backup data, but when we restore it, it's all going to be open as it were in production. So yeah, exactly that. And you could do this anyway, because again, this is where configuration can come in. You could send a simple SQL query to that and encrypt that data, but that's a manual task that you'd have to attend to. It's not going to be something that we can automate today.
There's a different thing here too, and I'm kind of wondering about this, because we used to back in the VM kind of world again, right? You have your database VM, you have your front end, you have your back end web server, whatever, and you kind of needed to ensure that you took backups of those at the same time, so they were in sync, right? So they were kind of at the same state. When you split everything up into different pods inside a namespace, inside of whatever, and you can interchangeably change components in there, how do you handle a state as a given in a given time? A given time period or whatever. How do you handle that in Kubernetes?
Yeah. So again, if you think about a database, we're going to use MongoDB this time, not Postgres, but same premise is, and I think this is visual, so I'm going to use the art of demonstrating with my hands here. Is that if you think about a database, it's got a constant flow of transactions hitting that. And if you just go and back up that LUN or that VMDK without telling that database anything, it's like pulling the power cable on that desktop PC. Like, will it come back up? Yeah, maybe. 90% of the time it will. it's a PC as well. Do I care that much about a PC? If that's a mission critical database, though, do I want to risk that unless I'm 100% sure? Probably not. And that's exactly the same in Kubernetes. We've got that constant transactional hit, and potentially in Kubernetes, now we've got the opportunity to use multiple different data services for the right job. Back in the day, in the scenario that you mentioned, Christian, you might have, right, we've paid a load of money for this Oracle database server or services. I'm going to, whatever database you need is always Oracle. The answer is Oracle because we've paid a bucket load of money for it. So now our Oracle server just gets bigger and bigger, and we've got databases galore on it. And because there is no other option, Oracle is the answer. Or Microsoft SQL is the answer because that's all we did. In the cloud native world, we've got the opportunity to use the right tool for the right job, the right database for the right job. So you might say, right, well, MongoDB is very good for this. MySQL is very good for that. Postgres is very good for this. And you might then end up having this, they call it polyglot persistence, in that you can choose the right tool for the right job. Anyway, we can get into that. I'm going to get back onto the transactional. How do we tell Kubernetes or this Postgres or MongoDB instance that we're going to take a backup? Well, it's exactly the same as it was in virtual machine world. Is we have to speak to the database, and we're going to take a snapshot now. Can you, depending on what's available within the data service, we're either going to pause the IO and it's going to write it to memory, or we're going to pause IO and it's not going to write to memory, but it's going to literally pause IO for a matter of seconds whilst we take a snapshot. Because then at that point, that transaction gets paused. It's either written off or not, but it's now we can pull the cable out. And now when we plug it back in, it's going to come back up. It's in a consistent state. Because what we're going to do at that point, once we've got a snapshot, and that might be a 500 terabyte database, but it's consistent. And now we're going to capture everything around that application. And that might be everything in the namespace. It also might also include things outside of the Kubernetes cluster. It might be a VM still that we can't containerize yet. It might be an RDS instance. It might be something else. So we're going to Kasten's got the ability to go outside. You can't see my whole hand going out here because it's going out of frame. But we're going outside. We're capturing everything in a consistent fashion, so that when we come to restore that, we know that the IO was paused, and then we say we're done, have it back, and that's seconds, but is a massive differentiator we have. If you look at open source tools like Valero, they don't have that capability. They're just going to go pull the cable out, hope for the best, try recovering a database that is moving fast like that, and that's as much of the competitive that I'll get into, but it bugs me because it's so important that we need to have that that we need to have that application consistent. That database is probably the most important thing in the business.
Is that why there still might be a lot of external to Kubernetes database services being used? Basically because we have known ways of handling the backup if it's in a VM or a physical machine instead of inside of Kubernetes.
So I think a lot of people choose PaaS-based services for ease. I don't think anyone wakes up and thinks about backup. Maybe just me. Yeah. So I don't think many. I think backup is very much at the bottom of everyone's shopping list. If you can make something easy, they might offload that to RDS. But equally, that costs a load of money as well. So I think that's a.
I'm going to say, Christian Lehrer wakes up in the morning thinking about cloud security. Christian Moen wakes up in the morning thinking about VMware licenses. That's just the way life is.
Yeah. No, but it's a sad bunch, isn't it?
Yeah, it is. We really should get out more. The other thing as well, though, is that there is still, to a certain extent, again, with Kubernetes, we're also down to the fact that a lot of this software is also written by or written for or by our customers for that perspective. It's a development environment as much as anything else. If you're writing microservices, then you also take responsibility for when things are consistent. So if your application, for example, is, let's say, for example, you're writing to that database, but you're writing to a table that contains information of your customer, then you're writing to a table that contains information about a logged call, then you're writing information about an invoice. You have to make sure that all three of those things are written correctly. Otherwise, that data is inconsistent. Therefore, no matter how consistent your database is, your application is still not consistent. So the customer still owns some responsibility. The backup application can only do so much.
That's kind of why I asked the question, because Kubernetes doesn't change any of this.
No, it doesn't.
It's not a magic bullet that does everything for you in any way. It's just a different way of deploying things. The same kind of you have to take the same amount of care with regards to how you store your data, how your network is designed, how you deploy things, and how you back it up, as in any other kind of infrastructure.
Yeah, but I suppose the benefit is if you're doing things in a microservice way, you can change. It's like you can change any single component. If you had a car, you can change any single component on the car without having to change the car. And you can do it while it's driving along. So you can go to wheel 2.0, take off, while you're moving, which something is very difficult to do with your average application. So that's really its benefit, isn't it?
Yeah, exactly. There are benefits to doing things in a containerized and Kubernetes and automated way, but it doesn't change the fundamentals behind IT infrastructure. That's my point. You still have to take care of the same kind of things. You need to ensure your I/O to your storage. You need to ensure your backups. You need to ensure that your network is working and that's secure and everything, right? We talked about private registries, right? If your containers are based on images that have security weaknesses in them, how do you handle that, right? You scan your registries and see if there is something there. Are there known things? Okay, in this version of whatever component, in this distribution of this Linux version, whatever, in the container, we need to update our registry to ensure that it's patched and then redeploy. Kubernetes doesn't patch that for you in any way, right? My point is, Kubernetes is a platform. It's a way of deploying things, but the basic IT infrastructure fundamentals still apply.
Yeah,
it's not a magic bullet in any way.
Yeah, you can do bad things, right? You can still do bad things in Kubernetes. I think speaking to like how we approach that software development lifecycle and security and making sure that we're the most hardened as we possibly can be for secure estates is, so we're in a lot of operator hubs, namely OpenShift, but most importantly Iron Bank, and Iron Bank is used by a lot of the like US Navy, for example. So making sure that you're the most secure, or you have the most secure software development lifecycle. So with that, that's our entry point. We don't then turn off the security fundamentals when we release it to everyone else from a Helm chart point of view. Everything that we do is first and foremost secure for Iron Bank, and then everyone gets that. FIPS 2 compliant, DISA STIG, and all of the other various like SBOMs. If you want an SBOM of what Kasten looks like, everyone's got that. We're running that scan. We're running that because we have to for this top level. And if we're asked to do that again for FedRAMP and other areas, we'll do that. And that's kind of our pledge to our customers as well, right? Because you've already got too much to worry about. You don't want to worry about another off-the-shelf software not being secure.
Yep.
True. Absolutely.
Again, 17 acronyms. I got 3. Anybody else?
SBOM, I can tell you.
But this is it, but I think that's the way it should be. Is the fact that you work to the most secure standard that you can, and then everybody else just shares. That's the ideal. But I completely agree with Christian Moll's point as well. Is the fact that just because if people decide to adopt Kubernetes, don't think that Kubernetes in some way makes everything so much more straightforward. It just makes it a much more active development environment is certainly the way I'm viewing it. Because like you say, if you have to patch something, well, there may be 37 different services within your application. And if 3 of those are subject to a certain element, then you've got to change all 3 of them to be able to fix that particular security issue. And then you've got to check all those 3 against every other element service that you have within your environment. So it's not suddenly making life any easier, or at least it makes it in a different way, I guess. But yeah, it's a different animal.
But then if you say you have to check for all the small things, you can also create individual tests for all your microservices. So you're getting faster, not only in patching, if you do it right, you also get faster in checking if everything is working again, because you can also do that on an individual basis. So
yeah, so really testing the calls between the elements of the application rather than seeing them run together. You can completely
monitor it all the time. And as soon as one of those parts is breaking apart somehow, you can interact directly without having to, get all the storage space being run over while waiting for the application to get slower or something like that. I don't know.
Right, so, cool.
But in general, totally agree. You still have to understand what you're doing, as it is basically with everything in IT. So,
yeah. Right, okay.
Been there.
So are we ending on the fact that containers is just like everything else? I mean, that doesn't seem like the way to end the podcast, does it? Let's be honest. Okay, but okay. So, any final words though, Michael? I'll go to you first. Any final words? If you have people out there who are thinking of containerized systems as a way forward, do you consider it to be a really positive step with regards to the way that's working for your customers?
Yeah, because of the speed of development. And I know we've just gone on and spoke about like the bugbear of having to patch everything or be able to make sure that we keep everything up to date. But by doing that and having those individual, in fact, I loved your car analogy, is that by having the ability to change stuff while we're going and moving quick while we're going is a very important benefit of having microservices and having Kubernetes. Is it allows us to achieve things quicker. It also allows for that scale out capability. So the Black Friday situation, not everyone is Amazon, but imagine that is that we need to spin up a load more resources for our end users, for our customers on Friday to be able to consume. Kubernetes gives us that capability. And yes, to a degree, you could do that with virtual machines, but you would almost need a lot more infrastructure to be able to do that. And you would need it 365 days of the year as well. You wouldn't just be able to burst into that. And I think that's also a massive benefit of this. But I will say, like, if you're running databases, one, it gives us the ability to choose the right tool for the right job. I think application consistency is often overlooked in regards to the backup piece. And I'll give a call out here. Like, we open sourced a tool called Canister, which is ultimately what we use, and we donated to the CNCF, the Cloud Native Computing Foundation, another acronym, as a sandbox,
extended
a sandbox
3-letter acronym as well. Yeah, sorry.
And with that is how we create the blueprints that go after those databases inside and outside of the Kubernetes cluster. So as a standalone project, it will give you the ability to dive into those data services and provide that consistency of that. We just, from a how does Veeam and Canister work together? With Kasten is the orchestration engine to Canister. So you're only Canister is only focused on the database.
Nice, good stuff. Christian Moan, any final words?
Yeah, I want to highlight one thing that Michael hasn't mentioned. Oh. No, the thing is, Michael has been doing something called 90 Days of DevOps. So 90daysofdevops.com is Michael's kind of project, highlighting his own journey and learning how the DevOps environment work. And he's been running for a few years now. And there's a lot of good content there. So if someone wants to after this rambling on, wants to actually read something and get acquainted with a lot of the things we'll be talking about, including the acronyms.
The acronyms are really important. So if someone wants to know what these acronyms mean, we're providing that facility.
Exactly. Write it into the comments.
Yeah. Go on to 90daysofdevops.com. It's Michael's project, and it's been fun watching that evolve through since 2022, I think. So there's a lot of good content there now, Michael. So well done.
Yeah, awesome. Yeah, and that was me just taking what I've done in the virtualization world and wanting to learn in public. Is that it's very easy, especially for a field CTO, to come out and make it look like he knows everything. None of us know everything, right? And it was important for us as a community to make sure that I don't know everything, and I'm going to go through Linux, I'm going to go through Golang, I'm going to go through containerization, and each one of them is like a section within 90 days, and it's all blog posts, and then it went into YouTube videos from the community. And it's all about learning in public and making sure that everyone's aware that we've got to become again the jack of all trades. Within that.
Every day's a school day, dude. So yeah, no, I completely agree. Christian, any thoughts to finish?
I learned a lot of things. Thank you very much, Michael. And I'll definitely take a look at 90 Days of DevOps.
Yeah, me too.
Thank you.
Thanks, Michael. Very much appreciate you attending. Great.
Awesome. Thanks for having me.